Hey guys, Mr. Gucci here, and this is your 4.1 worksheet wavelength and frequency homework help video. Let's get to it, all right? So, as always, the first step is to enter your name and then to enter your student ID. And I will use my classic 1, 2, 3, 4, 5, 6. All right, so let's get started. Remember, when you enter in your student ID, it creates a whole set of random problems for you. Okay, so these are the equations you're going to need for this homework. It's very important on this homework that you pay attention to the format in which you have to answer. Okay, this is going to be like some scientific notation formatting here, so you just got to be careful. I've allowed for a few ways for you to type it in and it still be registered correctly. Like I think it'll accept 3 or 4 different ways for you to type it in. So hopefully you'll find one of those ways that works for you. Okay. Anyways, let's get to it. Problem 1: a particular color of light has a wavelength of 568 nanometers. What is that wavelength in meters? Okay, so here we go. Here we go. So 500. Let me label this 2 because I'm going to upload this as well. All right, so here we go. So 568 nanometers over 1, and we are going to convert that into meters. So as we remember from our previous classes, all right, to do scientific notation, sorry, to do, what the hell am I doing? God. Oh, yeah. Dimensional analysis, all right? So we got to put nanometers on the bottom if we want to get out of it. And we got to put meters on top, okay? Because we're going to get out of nanometers and we're going to get into meters. Now, what is the relationship between these two values? Well, as I mentioned on the homework, 1 meter equals 1 billion nanometers. So we got to put 1 billion on the bottom. This is like the exact kind of number where scientific notation comes into play. So this is equal to 1 times 10 to the 9th nanometers. So 1 times 10 to the 9th nanometers is 1 meter. So really what I'm doing here is I'm just taking 568 nanometers and I'm dividing by a billion. I'm dividing by a billion. Remember, you don't need scientific notation to show you how to multiply or divide. You need scientific notation to tell you when you multiply and when you divide. Now, what I'm going to do here, guys, is I am just going to enter this in my search bar here. Okay, I'm going to do 568 divided by 1 times 10 to the 9th. And by the way, Google knows the E system, all right? So it makes it a lot easier than doing times 10 raised to the, let's see what it tells me. A 5.68 times 10 to the negative 7. So 5.68 divided by 10 7 times. Okay, great. So I can just write that in. Okay, this is going to be, the heck did it tell me it was again? 5.68, right? 5.68. Here we go. All right. So, wait, is that? Yeah, that's right. 5.68 times 10 to the negative 7th meters. So that is my answer. Let me make that little meter here. Wham, bam, thank you, ma'am. All right, cool. 5.68 times 10 to the negative 7th meters. So I'm going to go to my worksheet. I'm going to enter that in, all right? 5.68 times 10 to the negative 7th meters. Hey, that's correct. All right, great. On to the next one. A particular color of light has a wavelength of 6.73 times 10 to the negative 7th meters. What is that wavelength in nanometers? So 6.73. So let's do it. Here we go. So 6.73 times 10 to the negative 7th meters. And we're trying to convert this into nanometers. Well, again, you remember dimensional analysis. We want to get rid of meters, and so it has to go on the bottom. And we want to convert into nanometers on top. So this time it's 1 meter goes on the bottom, and 1 times 10 to the 9th nanometers on top. So in this case, we're going to end up multiplying by 1,000,000,000. So I'm going to go to Google, and I'm going to do, excuse me, my poor memory here. The heck was that? It was 6.73. Yeah, here we go. All right, so let me do 6.73 times 10 to the negative 7th, all right, times 1,000,000,000. I could just type in 1,000,000,000. 1, 2, 3, 1, 2, 3, 1, 2, 3, 9 zeros. And I get, one second, did I do 9 zeros? Oh, I did 8 zeros. Ha ha ha. All right, 9 zeros. 673 ta-da, nanometers. All right, that's the first two, just some simple dimensional analysis. Remember, guys, you do not need dimensional analysis to tell you how to multiply or how to divide. You just need dimensional analysis to tell you when you are multiplying and when you are dividing, okay? On to the next questions, all right? So for these next questions, we're going to use this equation right here. Speed of light, which is always the same value, it's constant, equals the wavelength of some electromagnetic radiation times its frequency. So if you know how large a wave of electromagnetic radiation is, and you know how many waves hit you every second, when you multiply them together, you will always get 3.00 times 10 to the 8th meters per second, okay? Because that is a constant. The speed of light does not change. So let's get to it. Let's try this first one. A photon of electromagnetic radiation has a frequency of 6.56 times 10 to the 14th. Oh, am I looking at the wrong one? No, 6.82. Yeah, sorry. I'm looking at the wrong one. Yeah, I'm doing number, oh, I'm looking at the wrong one again. My God, I scrolled down too far. Let me get back to where I am. Okay. Number 3. Sorry. All right, number 3. A photon of electromagnetic radiation has a wavelength of 6.12 times 10 to the negative 7th meters. What is the frequency of that radiation in hertz, rounded to 2 decimal places? Now, this seems kind of complicated, but I assure you it really isn't, okay? I assure you it really isn't. Let me make sure I fill this in for you guys. Okay, so here we go. Number 3. Now, for these next 4 problems on your worksheet, you are always going to start with this same equation. The speed of light, which never changes, equals the wavelength of electromagnetic radiation times its frequency. Okay, so speed of light equals the wavelength times the frequency. Now, we always know what the speed of light is. As I've said before, it never changes. The speed of light is always going to be equal to 3.00 times 10 to the 8th meters per second. Roughly 6.6, oh God, 660 million miles per hour, I believe, is what it roughly translates to, okay? And that's equal to the wavelength times the frequency. Now, it just so happens that you have been given the wavelength in this equation, all right? You were told that the wavelength of this electromagnetic radiation was equal to 6.12 times 10 to the negative 7th meters, okay? So you know that. And lastly, you're trying to find the frequency. Now, this seems like a really hard problem. Guys, again, this is not a hard problem. Please don't panic, okay? If I asked you, hey, 6 equals 2 times what? You'd be like, oh, 3, all right? That's easy. Well, this is no more difficult than that, okay? We want to solve for f, which means we're going to have to divide both sides by 6.12 times 10 to the negative 7th. All right, divided by 6.12 times 10 to the negative 7th. Okay, so there we go. So this is what I got to put into my calculator. In this case, I'm just going to use Google. Okay, so here I go. I'm going to do 3.00 times 10 to the 8th divided by 6.12 times 10 to the negative 7th. And what I get is 4.90 times 10 to the 14th. 4.90 times 10 to the 14th is my answer. 4.90 times 10 to the 14th. Now let's see here. Did I get that right? Times 10 to the 14th. Hertz. Is that 0 counted? Let's see what happens if I leave it out. Oh, okay. Well, that's just a little, little mistake there then. Apparently I say 2 decimal places, but if it ends in a 0, the auto checker won't make it correct. I wish there was an easier way to do that. I guess I've already distributed this homework. So if it ends in a 0, I guess you leave it out. All right. Good luck. Sorry about that confusion, guys. All right. All right. So there we go. So that's the answer to that question right there. All right. So frequency equals 4.9 times 10 to the 14th. All right. 4.9 times 10 to the 14th. 4.9 times 10 to the 14th hertz is the answer. Okay. Okay. On to the next one. All right. Number 4. Is there room here for it? Ah, there is. So once again, start with the speed of light equals the wavelength of the light times its frequency. Let's take a look at what number 4 is asking you. Number 4. A photon of electromagnetic radiation has a wavelength of 6.82 times 10 to the negative 7th meters. What is its frequency? Okay. Well, guys, again, this is essentially the same question. All right. So the speed of light never changes. The speed of light, c, is always going to be 3.00 times 10 to the 8th meters per second. Okay, it's the speed of light. It does not change. It is the same throughout the history of the universe. All right, now you know what the wavelength is. All right, the wavelength, this lambda, this weird symbol right here, this wavelength is equal to 6.82 times 10 to the negative 7th meters. All right, and then you have to find the frequency. You got to find the frequency. Okay, so once again, this is the exact same thing. To get the frequency by itself, we have got to divide both sides by the wavelength. It cancels over here. So the frequency is going to equal 3 times 10 to the 8th divided by 6.82 times 10 to the negative 7. Let me go back to my thing here. So 3.00 times 10 to the 8th divided by 6.82 times 10 to the negative 7. And I get 4.40 times 10 to the 14th. All right, so here we go. So this is going to be 4.40 times 10 to the 14th. That is correct, all right, and it's in hertz. Now listen, guys, some of you might be getting the correct numbers in the front of your problem, but your exponents are way, way off, okay? Maybe you're getting like an exponent of 1 instead of 14 or something like that. If that's happening, it is because you are not using the E button on the calculator. You are doing times 10 raised to the whatever, and it is majorly throwing you off, okay? So try and use that E button to stand in for the times, the 10, and the raised to the, okay? Cool. All right. Oh, what do you know? I gave you 2 problem 6s. That was dumb with me. All right, so here we go. On to problem. I'm going to cut this video and I'm going to do another. All right, on to the next one.